Hey everybody, I just wanted to make a short video about the brightest supernova that's ever been recorded in human history. So, let's get into it. Okay, supernova 2016 APS, star explosion makes history. This star was about 50 to 100 masses of Earth's sun. So that's a really large star. Basically, a supernova is essentially the death of a star. Not all stars die the same way. There are two known types of supernovas, and then also the white dwarf. And the type of supernova is actually dependent on the star's mass. And I have a chart later on that we'll get to, and I'll kind of show you the dividing line between the two types of supernovas. So, astronomers discovered the brightest supernova known to man. At that time, it was not confirmed to be the brightest supernova just yet. Astronomers were still observing it. Okay, this supernova is said to have 10 times more energy than the sun will emit in its entire lifetime. So just so you know, the sun has a lifetime of about 10 billion years, and right here, 10 billion year lifespan. And this supernova was so powerful that it exceeded the amount of energy that the sun will emit in 10 billion years. So, what's even more fascinating is how long this supernova was able to last. Normally, they only last for a few months, but this one lasted for a couple years actually. So, that's actually pretty crazy. And then, why did this supernova explode? This supernova had likely originated from a massive star in the universe, but the star did not explode on its own. A massive shell of gas was shed prior to the explosion, and the collision of the explosion debris is what made SN 2016 incredibly bright. So, near the end of the star's lifetime, it does what is called a coronal ejection, and that's the outer layer of the star, and it gets ejected out. And then the core of the star collapses in on itself and then explodes. And then as the core explodes, it's going to collide with the coronal ejection later on. And they're saying that that collision is what made this one so bright. So here I have a artist's impression of what the supernova looks like. It's really bright. Here's the star, and then here's the coronal ejection. Okay, and then as the explosion happens, it interacts with this coronal ejection and makes the supernova extremely bright. So just a quick few facts. This supernova's distance is about 3.6 billion light years away, and a light year is the distance light travels in 1 year. It took that light 3.6 billion years to reach us. So this supernova actually happened 3.6 billion years ago, which is a really long time. So since our sun is only about 4.5 billion years old, this happened about 1 billion years after our sun was even born. So this is a chart, the main sequence of stars. Okay, this kind of breaks down luminosity over here on the vertical axis, and then surface temperature here on the horizontal axis. As you go left on this horizontal axis, it's increasing in temperature, and then to the right is decreasing in temperature. And then as you kind of go up and to the left, that's going to be a more massive star. So our sun is located right here, and it is one solar mass, because what we do is we compare every star to our star, and basically our star is one solar mass. It's kind of like the base of what we compare other stars to. Okay, so there are two different types of supernovas. There's a type 1 supernova and a type 2 supernova. Okay, so in between 1.4 solar masses and 8 solar masses, that star will undergo what is called a type 1 supernova. A type 1 supernova is really important because it is what is called a standard candle, which means it has a very constant luminosity, so a constant brightness. And so we can use its apparent brightness to gauge how far away it is. So it's one of the main tools we use to see how far certain galaxies are from us. And then anything above 8 solar masses, which is probably right about here and up, that's going to be a type 2 supernova. And what that is that's when the core's temperature drops so significantly that it's not able to have enough pressure to counteract the gravity. And so gravity makes it collapse in on itself, and then it explodes. This star was about 50 to 100 solar masses, so it's like way up here in the upper left corner here. And that is what made it so massive. So okay, well, that's all I have for today. I just wanted to do a quick short video about the brightest supernova ever recorded in human history. And if you liked this video, definitely hit like. And then if you don't want to miss any future news that's coming out, definitely hit subscribe. So, thank you.